I'm going to begin with a small demo using electric field hockey. Then I'll walk back to show what it was created with and how the demo was made. Then we can make a few changes and see them happen in real time. Okay, so we are using pieces of paper to represent different bit of script. And so in this case, we'll be using some smaller pieces of paper that I have here. And I have a physical setup done here. So at the moment, it is just a webcam on a tripod pointed down at a monitor. And that is important because on that monitor is one of the screens from Paper Playground, which is one of the tabs, and it is put to full screen. Another way you could do this is to use a projector, or you could just look at the tab. Is where the scenery scenery bit is drawn. There we go. So to kick us off, I'm going to come over here to the camera. And so this is seeing exactly what you just saw, that webcam pointed down at the screen. And I've already done the calibrations and stuff here so that the camera will recognize the pieces of paper. And you'll see that the papers I use here, because I'm using this monitor as a sort of proxy for a projector or anything like that, I just find it a little bit easier to move papers around. But you'll see that my papers have some holes cut in them. And that's to let some of the visuals through that we have with our demo here. So I have a few different papers here with the charges. And you'll see them drawn here on the monitor. And I can show everything moves a little choppier on the camera screen here. But if we're to watch it in real time here, things tend to update and move a little more smoothly. And I'll show that again when we get some of the other pieces running. So, so again, this piece of paper here just has a few things, a few pieces of code in it to instantiate this charge. So here we have a positive charge. It has, it's somewhere on the screen, and it has a little circle drawn for it, a little blue circle, if you can't see that. And I have a couple others. I have a negative charge over here too. And I can put that in here in the field. And I drew, we have a few walls. So this paper here, to mimic some of the walls that were, if you've ever played electric field hockey, there's a few walls that you can put in. And this will draw a little rectangle there. And we have a few other pieces. We have a target. So this again is a separate script here to draw this target here and instantiate that. And that's actually enough for us to get started. So we have two different ways of putting sort of scripts into life. One is the physical papers that you saw here. The other are sort of preview papers. So if you don't need to move a paper around, but you need the code to run, this is a great way to do it. Also a good way to sort of debug things. So the program that sort of runs most of it, keeps track of most of what's going on for electric field hockey is this test charge one. And just like electric field hockey, generates a small positive test charge and sort of animates through according to the electric field that it feels. So we have a positive charge over here and a negative charge over here. If I were to, I don't know, put that target in front of that negative charge, something might happen. So I'll go ahead and start that one. And it behaves just like a real piece of paper. We'll see that the charge here is born. spawns in and is following the electric field gradient. And I can move this around. It's dynamic enough if I wanted to give that thing a little push. And it hit a bound, so it's not too happy about that. It'll reset back to the start. But I can let it do that again, let it reset. And again, everything moves a little bit more smoothly over here if you were to watch. And it's going to zip up. Oh, and it hit the goal. So we see it kind of get really big when it does that for what I've programmed it to do. So yeah, we can now get a little fancier here and start adding in some more charges. So I could add another charge here. And since we have all that positive charge over here, it's really pushing the small test charge that way. And we can start making it a little bit more complicated. Maybe we move this up a bit. So now it's still making its way over there, but let's give it maybe some more curve. Let's put an obstacle in the way here so that we have something to work against. We can put a few more obstacles in too. There's another one. Sure. Also one there. So if we want this to get to the goal now, and let's say we don't want to move the obstacles, then I'm going to have to move these around. Maybe get it a little extra oomph. It sails around and into the goal. Okay, cool. And then if we really needed to, we have another negative charge to help things along. But now we also can add some descriptions. So here I'll add a grid. And again, this doesn't need to be moved around. So I'm just going to make it as a preview paper. I'll move these kind of out of our way. And I have a paper here that adds a few descriptions, and it adds a description to the charges as well as to the target we have there, that goal. That's on.
Goal.
So we have a simple
Goal.
description in there. Just when the test charge hits the goal, tells us goal. And also is another that added in. So if I were to remove that charge.
Negative removed from right top. Goal.
And there it makes use of that grid.
Negative added to left top. Goal. Goal.
And yeah.
Goal.
So there's a sort of simple electric field hockey demo. And of course you could test different configurations of the obstacles. You could move the charges around. And we can start playing around with adding other modes to this. We can start adding some sounds. And we can change the descriptions. We can add some more descriptions. And just sort of very quickly play around with this idea. So I'm going to walk back a little bit to show how this was created and how we can change it after we've seen sort of what it can create. So if we take a look over here at our creator, this is our sort of abstraction for writing any of the JavaScript code. So if I can look really quickly back, if I look at any one of these scripts, any one of these papers, so charge 1 here, which was this paper right here, is it's right here. So I can take a look down and see all of the code that's been added to it. And the developers who are watching this would be, this should look all fairly familiar. There's a lot of FET components, and then there's some abstraction of the FET-lib library. But largely adding model components, view components, controller components. And that's a lot, but I didn't write any of this. because I don't know how. But I did make this whole thing myself. So if we go back to Creator, what we'll do here, we'll start kind of simple, and we'll make a new project. Let's pretend maybe that I am starting to create electric field hockey. So I've created a new project. It's totally empty. And all right, well, I've got my idea already. I know I need some charges. I need the test charge, need some walls. So we could kick off by creating a new program. So this would be represented by one of those pieces of paper. And let's say I have a piece of paper right here. This is 1176. So I could change that. And each of these numbers here is tied to the sequence of dots that you see here. So 1176 means whatever series of colors this is. So we can create here if we want to start adding things. So I want to start adding some of the code. I want to create a charge. I know for a charge, it needs to have a charge. So there I know it would be a number value of some sort. And it's going to go from -1 to 1. And give it a default of, we'll make it a positive charge, give it a default of 1. Give it a name. It's the charge of the charge. I know it has to live somewhere. It has to be somewhere on the screen, and I need all that information to calculate the electric field. So charge 1 position. And that is also, that is a position component. And so here I'm just going to keep building up all the components that I need and that I want to be able to talk to each other across the different programs. And again, since I want to be able to move these charges around, I chose to put this in its own program. And I haven't started adding anything about the test charge or the electric field calculation or anything like that yet. So charge 1 position, create, and I want that charge 1 position to follow the piece of paper. And so that's where our controller components come into play. So I create a new component again. I'm going to go create a paper component. I know that I want to link it to something about the piece of paper. We also have links and animations if we wanted to control things that way. So here I want to select one of those model components that I created. I want it to be the position. I want it to, of my options here, I can match the center. I can match the X position or the Y. I want it to follow the center of the paper. Of course, we need to give this a name. Charge 1, position, controller. That should be good. Okay. And now we see one of the other big pieces of Creator is that it highlights the relationship between the different components. So if you are trying to keep track of what the different relationships are, what's controlling what is, what's dependent on what, this is one way to do that. And we can see in particular, this one's color-coded to match a controller model connection. So if we want to just keep building this up, let's create a circle. Sure, let's create something to look at. And we can do that by creating another component. This is all about creating components and linking them together. Create a circle, so a view, a shape, circle. And my goal here is to just keep it with the paper. So I don't want it to be anywhere particular on the screen. I want it to be Fill light blue, sure. We'll give it a blue outline. Make it a little thicker for fun. And radius, well, let's see how big that is. I'm not sure. So then what I'll want to do is set those two things together. I want the circle to be in the same place where the charge 1 position is. And I already have that, and that's already being controlled by, all right, quick redo. So charge 1 positions be controlled by position controller. I clicked out, so I have to quickly redo that. Okay. So yes, I want it to depend on charge 1 position. And then as we have it now, that gives us some, kind of pre-generated documentation to say what we can do with it. And this is where some of the limited code writing comes in. But a lot of these are still abstracted out to be a bit simpler. And so for this one, I know that I want to set the center of the view to the charge 1 position. So I'm going to use these two right here. Set center X. And set center Y. And I know that I had these components up here, the X position. I'm just going to copy paste that into there, and the Y position. And that should be about it. I don't need to change anything else about it, though I could. And let's give it a name. Charge 1 view, picture, image, circle. Sure. Okay, and so now I can see that charge 1 circle here depends on charge 1 position with our model view connection. And why don't we check to see if it works? So I can go ahead and I have that. I have this piece of paper that I set it to, 1176. So if I go ahead and send this to the playground, to the camera, maybe save it first, then it should create our circle. So all these will stop working, but I don't need them, so I will set them aside. Put that one down, and we can see, well, behind this, there is a fairly large blue circle in the background underneath, back there. So that worked. It's pretty big. So I would probably want to pop back into Creator, go back to my circle, come down here and say, well, that's much too big. Let's make it like, I don't know, a lot smaller. I can save that and then send it again. This is our quick iteration here. And we can see it changes right there. It's a lot smaller now. Okay, so then, well, what else do we want to be able to do? All right, so then I'd want to start adding other things like the obstacles, the walls. So I could create a new program for that. I can also, depending on what templates exist, I can create something new from a template. So I know that the wall is sort of like a bound. It's an area that I want to be able to say something about or do something with. So I can create a displayed bounds template here. And then I can just edit that one. So the model here has a bound that matches. I have the bounds right here. 172. We can create. Let's use one of these. 648 for this one. So 648. So this one already creates a bounds again and creates a view for it, so some rectangle. I want to make it move with a piece of paper. So I chose my piece of paper, this one right here, and I'm going to create a way to change it. So if I want to change something, that's going to be a controller. Want something to do with the paper again. So now I'm going to find the bounds, and I would like the bounds to match the paper size and location. So bounds model controller. Okay, and that should be all I have to do. So then if I send that to the playground, I didn't actually check to see what the rectangle looks like, but I guess we'll find out. I'll go over to the camera. We still got our charge there. We'll toss this one in, and I can see my rectangle. It's slightly hidden behind the paper. If I rotate it, it'll kind of get bigger according to the biggest sides of the maximum X and Y of the dots here. Just give it its size. We didn't set a way to rotate with it, so I don't expect it to rotate. Okay, and so that's how we get started. And as we want to create more and more things, such as the test charge, I could create a new program here. I could populate it with the test charge, the test charge position, and then I could try creating a, for instance, a control or link component here to start making some calculations and changing things. I could animate the test charge, and I'll give a quick look of what all that looks like when it's put together. So the original demo that I showed is this electric field hockey one here, with all of the papers that I had before. And you can see it's a little bit more complicated. There's a few more arrows to see, but we see I have our 4 charges, and each one of these has its position, charge. We actually make use of an array so that we can add and remove the charges and not cause any problems. We have array components for that. I'm controlling its position and creating a circle for it. We do that for each of those. And in this case, all I had to do was create one charge, and then I just copied it a few times and made a few changes to create these other charges. So that was actually pretty quick. And then the main program running everything was this test charge one. And this is where you see a lot of the other pieces. But this is where the test charge comes into being. So giving it a position, a charge, a scale if I want to change its shape dynamically, which we do. You saw it get kind of bigger whenever it hit the target. We gave some extra bounds in here, other pieces of the program that I don't care to associate with, where the paper is or how the paper is moving or anything else like that. So this one looks a bit larger and has sort of the backgrounds of everything. We have generated the arrays that will sort of keep a running list of which charges are actually in the field here in the play area. And then our calculations. So our electric field magnitude, you can see is a derived value here. With the test charges, you see there's a lot of linkages between the net force and some of these components that are just checking to see whether or not our test charge position is inside of any of the obstacles. Is it inside the goal? And so if we take a look at the electric field magnitude, we can see all of the code that goes into that calculation. And I will note here, we select any of the dependencies that we need. Went with the test charge position that we need, of course, for electric field. I need to know all of the charges and their positions and their charges. And so all of that comes from charge array, which just, again, populates from which of these these charge papers are in view. And of course the test charge. So that's all the information we need to calculate the electric field. And that's calculated here, but I also didn't write any of this. So what I did was I selected each of the things that I knew were important. And I came down to the AI assistance and I had asked it, I want to be able to calculate the total electric field on the test charge. Given the positions and charges of the charges in the charge array. And it came up with this. It may have taken an attempt or two, but we got something functional here, and I copied and pasted it, and all's well. So then I know it returns the field, and then I can use that somewhere else. And where do I want to use it? I want to use it in the animation where test charge is. I want to use it to calculate the forces on the test charge. So the force X and force Y. And so if I look at each of those, so net force X, you can see that, it's just another simple calculation. In that case, I didn't need to use the AI, but and we use all that to drive the test charge, right? So to show it sort of moving throughout the field. And so same thing here. I didn't generate any of this. I asked the AI, though it's just a simple case structure, but I asked it to for each of the dependencies that I selected to check to change the test charge position depending on each one of those, and to calculate to set a new test charge position according to the electric field that it felt. So calculating, asking it to please calculate the position change using the force and the change in time. So that just works. So a fair bit of code throughout all this that so far I've had to do little with. But of course, I can always come in here and see with some of our abstracted functions and stuff, anything that I want to be able to quickly change. And it's all kind of readily available. Okay, so that was, again, we have the obstacles, and each of those get their own paper, and those are just a couple components that we popped in. Some of them should be fairly familiar at this point. There's the bounds, there's the controller to bind the bounds to the paper, there's the view, and there's the array item that we're making use of. Same thing for the target. The target is just another bound, and it's just being bound. Its position is set to the piece of paper. And then we have our descriptions. Our descriptions are pretty easily added here too. So for instance, the goal description is as simple as checking to see where the test charge position is, and asking whether or not it's in the target bounds, right? So if I want to read goal, I want to make sure that the test charge is in the bounds. And so the bit of code that's written there, again, you can just ask the AI for that. For instance, I want to return a string goal when the test charge is in the target bounds. We'll see how it does this time. Okay, that looks about right. Looks exactly like what we had up there. So, that works. If I needed to, I could just come up here and paste it in. Save changes. And then similar, I have a charge description. Sorry, an add and remove description. So if I want to have something about it being added, we have our grid set up. So this is another great chance to look at the templates, but I set up a sort of a 3x3 grid, which looks fairly complicated, but a reminder for any of these papers, anything that seems reusable, we can create from template. In this case, we already have a described grid all set up, so I could create that, and a lot of that's already in place. I can delete any excess stuff. And so that's how I had created this grid here, and I did a little bit of renaming, but all that was done very quickly. So we have the grid. We know the sort of bounds for each of those grid cells, and we also draw those the red boxes that sort of define that grid. But then we can use that for our descriptions. And so if I want to describe where the charge is getting added, and if you recall, you'd hear that it was, the negative charge was added to the top right or right top of the play area. So in this case, we are making use of our arrays again to check to see where those charges are getting added to the array, whenever they come into view. And we're using all of our bounds that we created with the grid. And again, this is another great place for AI to come in. But I gave it sort of the simple description of, hey, please create return a string for each bound if the charge array added item is in there. So if a new charge is added to the array and it's in one of these bounds, I want to return the string of the bound it's in. And it generated all this for me. And then same thing, just to indicate that there's a charge. So, I mean, all these are fairly simple, but this works. And so in the end, this returns the string of whatever the charge of the added charge was, and then where it was added. So right bottom, center bottom, and so forth. And those can be easily changed. So if we set ourselves back up here, let's give ourselves our wall. Just gonna put ourselves back into that configuration that kind of worked. Church 3. There's a wall. Charge up there. Okay, we got all our pieces back in place. We got our charges, our positive charges over here, our negative charges over there. And we've got this other preview programs on.
Positive added to left center. Goal.
Okay. So it's going to keep doing that in
Goal.
the background, but we can come over here and say we just
Left
want to
window.
iterate on
Position
this.
reset. Left window. Position reset.
Oh.
Left window. Position reset.
Oh, I see
Left
what's
window.
happening.
Position reset.
It's hitting the charge
Left window. Position reset.
and whipping
Goal.
whipping out across the
Goal.
universe as it hits that charge.
Wall hit. Wall hit. Position reset. Goal. Goal.
Okay, so these, like I said, should
Goal.
be fairly easy to change. So if we
Goal.
were to say, oh, well,
Wall-
this isn't
wall
actually
hit.
the
Position
best way
reset.
to do it.
Goal.
I'm going to pause that real quick.
Goal. Goal.
And we could just simply, I don't know, so maybe added to wasn't the best way. Maybe we wanted to say, we wanted to give a try of this instead. New positive or negative charge at left bottom, right bottom. I don't know that this is the better description, but we could try that And we could also try it by adding it to different papers. Maybe I save this one and I duplicate this whole thing. And in this one, I decide I want to keep what we had before. Oh yeah, this is removed, added to. Maybe we wanted to keep that. Maybe that was better. Cool. And then we get two different papers and swap them in and out just based on those choices and be able to quickly decide, show for ourselves, show to whoever we're talking to. This one works. This one doesn't. Here's our two options right side by side. And we can do that as much as we want. We can do that with descriptions. We can do that with sounds. Very easy iteration. Of course, I don't want to do that right now, so I'm going to get rid of that. And then, lastly, if I'm going to keep this going and nobody has fully tuned out at this point, we can start adding a little bit more. Maybe I really wanted a sound to go with the target when there's a goal that's hit. Then I could create a new component. I can create a view. I want a sound. I want, we have a bunch of sounds that are already here, but we go with a loon call. And I want this to only trigger when the test charge position is in the target bounds. And let's pretend I have no idea how to do that. I want the sound to play when the test charge is in the target bounds. See what it does with that. Okay, that looks reasonable to me. Looks like a lot of the other code that we've written. So that should just work. Let's find out. Oh, I have to give it a name. Target hit sound. Let's find out if there's any new sounds. Oh, apologize. I've got some things sitting at the edge of the boundary. There it was. Every time we hit the goal, we're going to get a loon. But that was fairly easy to add. And I'm going to pull that out just for now.